Welcome to trigonometry. If video lessons are new to you, I encourage you to just follow along as I go through the lesson, writing down what I write down to help you as you work on your homework. I encourage you to have a calculator and practice the calculations that I do, just to make sure that you can enter them in on your calculator, and maybe have a different color in case you want to just have a little clarification as you go through the lesson. Chapter 6 is just titled Trigonometry. 6.1 Day 1 is called Angles and their measure. We'll spend 2 days on this lesson. In Day 1, we're going to look at angles on a coordinate plane, and we'll mainly focus on degree measure. We'll also have a little bit of application with real-life problems at the end. In Day 2, we'll look at radian measure, arc length, and area. The definition for trigonometry. Trigonometry is the measurement of triangles. And we'll focus specifically on angles and sides. Now within those angles and sides, your triangle can be actually drawn in any one of the 4 quadrants on a coordinate system. Today's focus will be looking at putting angles on a coordinate system and kind of determining their measure. An angle in what's called standard position is always going to have an initial side and a terminal side. By definition, the initial side is always on the x-axis, and it's technically a ray. The vertex is the center of your coordinate system, and over to the right would start a degree measure of 0 degrees. That's the initial side. Notice my terminal side is over on the left, but it can be in any one of those 4 quadrants. Let's define the quadrants. In that top right corner, that would be quadrant 1. And your angle would be anywhere between 0 and 90 degrees. If it goes over into the left where that terminal side is, that's now quadrant 2. Anything that's in a quadrant 2 would be between 90 and 180, halfway around. Down below the x-axis on that left-hand side is quadrant 3, and over to the right would be quadrant 4. Now your terminal ray can be in any one of those 4 quadrants. And based on its location, we can give an approximate degree measure. Now, how do we know which direction to go? It depends on the kind of angle you're asked to create. If you want a positive angle measure, you're going to go in that counterclockwise direction. Your angle will always start on the right-hand side at 0 degrees and will rotate backwards kind of around the clock or counterclockwise. So that terminal ray, again over here in quadrant 2, would be positive. If you want a negative angle measure, you'll still start at that 0 degree, but you'll go in a clockwise direction. So notice down here, the terminal ray ends up in quadrant 4, but that's going to be a small negative degree measure. So let's put that to the test. Let's go ahead and sketch a 145 degree angle and then a negative 145 degree angle. To do that, I'm going to just create a really quick coordinate system, knowing that we start our initial ray always on that right-hand side at 0 degrees. Put your vertex right in the middle. All the way up to the top is 90 degrees, and all the way over to the left would be 180. 145 is kind of in the middle, a little bit closer to 180 than it is to 90. So what I'm going to do is just kind of draw an arc like you see on those other 2 pictures from that x-axis somewhere over here into quadrant 2. We're just approximating. I'm going to take my vertex and go through that curve or that arc over here on that left-hand side, and we'll approximate that at 145 degrees. Now the difference between a positive and a negative angle is really just direction. The initial ray and the terminal ray will be the same amount apart, just in a different direction. So now I'm going to start my terminal ray over on that right-hand side with a measure of 0. But if I go backwards or clockwise around the coordinate system, the bottom will be negative 90, and then all the way around will be negative 180 on that left-hand side. So we just need to go somewhere in between, a little bit closer to the x-axis than the y-axis. And that is a measure of negative 145 degrees. Utilizing that terminal side, we can generate many angles that would start and end at the same location. But the angles actually have a different measure. Those are called coterminal angles. Angles that share the same initial Oops, I just spelled that wrong. So I want to make sure you guys are paying attention. Initial and terminal rays. And rays are the same as sides. What you do is if you take a look at the picture on the right, notice you've got an alpha or an A symbol and a B, a beta symbol. It just means depending on the direction that you go, to get coterminal angles, you would take your original angle, alpha, and you'd add or subtract a total of 360 degrees to it. And that would give you positive angles and negative angles, as big or as small as you'd like to make them. We'll do a little bit more practice with graphing, and then we'll look at coterminal angles. The first angle I want you to graph is 58 degrees. So if we sketch kind of where that would be located, we're just going to end up in quadrant 1. Your initial ray is over here on the right at 0. 58 is less than 90 degrees, a little bit more than halfway, so we'll just kind of approximate that location. There's your 58 degree angle. I want one positive and one negative coterminal angle. What that means is I want it to share the same initial ray, and they all do, but I also want my two angles to share the terminal side. To do that, I'm going to take my alpha, my original angle, and if I add 360 to that, I get a pretty big angle, 418 degrees. And you can add 360 as many times as you want. What would end up happening is you'd start on that initial side, but because it's greater than 360, it would go all the way around and then end at that same terminal side. Cool, huh? 418 degrees would be in quadrant 1 at the same location as 58 degrees. If you ever want to get a negative angle measure, order matters when you subtract. Always start with your original angle, but now if I subtract 360 degrees from it, I get a negative output, negative 302 degrees. And what that would mean is we'd start on our initial side, but a negative angle goes in a clockwise direction. If I go halfway around, I'm at negative 180. And if I go to the top, I'd be negative 270. So I have to go just a little bit further to get to that terminal ray or terminal side at negative 302 degrees. And that's all you do. Our next angle is already bigger than 360, so we'll have to see what we're going to do here. 500 degrees. The first thing we'll do is we'll just sketch where that would be located. Start at my terminal side over here at measure 0. Now 500 is already bigger than 360, so we have to go all the way around, one full loop for sure. But then to get to 500, if we subtract the two, 500 minus 360 would be 140, so we have to go all the way over into quadrant 2. That's a really big angle, a total of 500 degrees. To get coterminal angles, remember we can add and subtract as many multiples of 360 as we want. Since 360 is one full revolution, it would end up at the same terminal side or ray each time. It's easy enough just to take your first angle and add 360 right to it. We got a really big answer, 860. But watch what happens when we take that first angle and try to get our negative coterminal angle. If we subtract 360, that's positive 140, so that's not negative. That means we have to subtract again. And you just keep subtracting as many multiples of 360 until you get a negative answer. Now if we take 140 minus 360, we get negative 220 degrees. Now notice all three of those angles would actually be coterminal. You could say 140 for the positive answer if you wanted to. Finally, let's take a look at that negative measure. Negative 134 degrees. Can you visualize what quadrant that would be in? A negative measure goes in a clockwise direction. We'll start with our initial ray on the right, again at 0, no matter what direction we go. Negative 134 would go in a clockwise direction at about the middle of quadrant 3 over here. So that would be our negative 135 degree angle. To get a positive coterminal angle, take that initial measure, and we're going to, not 135, wow. How did I get 135 out of that? There we go, we'll fix that quick. There we go. All right, to get our positive measure, let's add 360 to that. Negative 134 plus 360 is positive 226 degrees. And that would be if we took our initial ray. 226 is greater than 180, so that makes sense. It would go all the way down into quadrant 3. And if we get a big negative angle, that would happen by subtracting 360 for a total of negative 494 degrees. And that means it would start on that initial side and now go clockwise all the way around, one full revolution, and then all the way over to negative 494. Those are your coterminal angles. Angles are commonly measured in degrees, and usually we look at whole number angle measures. But there are instances where you're in between angles, and we can label those measures either in decimal form or in minutes and seconds. To think about degrees, minutes, and seconds, 1 whole degree is equal to 60 minutes. So that single dash means minutes, almost like an hour. 1 minute is equal to 60, and then we use a double dash for seconds. Oops, that's a double dash right there. There we go. That means 1 degree would be equal to 60 times 60, or 3,600 seconds. And we can convert from one form to the other. This is where you'll want your calculator. When you convert from degrees, minutes, and seconds into decimal form, this is pretty easy. You're going to take your whole number degree and just kind of leave it, which is nice. You'll add to that the portion of a degree in terms of minutes. Now there are 60 minutes in a degree, so if you have 21 minutes, 21 over 60 would be the decimal version of that answer. And then we'll add the number of seconds as well. If you have 33 total seconds, we'll take that divided by 3,600. That's how many seconds are in, I'm thinking as fast as I'm writing, sorry, or faster actually. That's how many seconds are in a degree. So 33 divided by 3,600. The nice thing about that is you should be able to enter all of that in at once. So type that all into your calculator and press enter. You should get approximately 37.3592 degrees. So just under half of a degree. Now tomorrow we'll look at converting from decimals back to degrees, minutes, and seconds, and we'll finish our lesson with complementary and supplementary angles.